All right, so we're going to give 5.3 a second take. um, so, double angle, power reducing, and half angle forms. All of these formulas are found in your textbook, but they are also found on your trigonometric identity reference sheet. We've got them here, here, and here. Now, your textbook doesn't have all of them listed in this reference box as far as, well, never mind. Yes, they do. It's right there. And then they've got these two right here. And then the tangent one, these two extra tangent ones, they are also right here. I did try to make sure that this matched your textbook, so I think I did go in and update that and just forgot I had done that. So yay me. Okay, so on your trigonometric identity reference sheet or in your textbook, these formulas are available for you. Okay, you are responsible for knowing how to use them, so make sure you practice these so that you know how to use them. Okay, this first one is deceptive because it looks like it's actually pretty easy, and this one has a little bit more work involved than the average person would expect, and that's also why for this section you're skipping certain ones, so you're only doing every other one or something like that. You're skipping 10, 12, 14, I think it was, but it's because these can be a little bit more meaty than some of the other ones. All right, so use the given information to find the exact value of each of the following. Okay, so we've got sine 2 theta, cosine 2 theta, tangent 2 theta. Right away, we know that we are talking about the double angle identities. Okay, so that's these right here, and I've put them here just as a reference, but that way you can see them right away. Okay, sine 2 theta, and we've got this formula. Now, we are given that sine of theta is 3/10, and that the theta lies in quadrant 2. That's important because that's going to tell us where our triangle is, and then that is also going to tell us what the different measures of the sides are. So I know that sine is opposite over hypotenuse, so that's going to be 3/10. I'm going to autofocus this real quick. And then in order to find the other side of the triangle, I need to use my Pythagorean theorem. So looking for this missing side, I've got 3 squared plus a squared equals 10 squared. So 9 plus a squared is 100. A squared equals 91. Take the square root, and so a equals square root of 91. But this is on the left side of the y-axis, so then we know that this is going to be negative square root of 91, because as the numbers go farther left, we know they become more negative. All right, so now I've got the sine, and let's see, I'm going to need cosine and tangent. All right, so we've already got the sine. Cosine of theta is going to be adjacent over hypotenuse, so it's going to be negative square root of 91 over 10. And then tangent is going to be opposite over adjacent. So tangent of theta is going to give me 3 over negative square root of 91. Well, if I rationalize that, this is going to end up giving me negative 3 root 91 over 91. I shouldn't have put a multiply there. So these two are equivalent statements if I rationalize it by multiplying both the top and bottom by the square root of 91. Okay, so I have all of the information I need now to find the exact value of each of these expressions. Okay, so I'm going to draw just a little line here. Okay, so I've got A for sine of 2 theta, and that is going to be 2 times my sine theta, which in this case is 3/10, times cosine theta, which in this case is negative square root of 91 over 10. So if I multiply this together, all the numerator values, all the denominator values. I get negative 6 square root of 91 all over 10 times 10, which is 100. 6 and 100 are both even, so this can be reduced further by factoring out a 2. Okay, so now there's your A, sine of 2 theta. All right, B, cosine of 2 theta is equal to cosine squared theta minus sine squared theta. So I need to find my cosine, and that's going to be negative square root of 91 over 10 squared minus my sine theta, which in this case is 3 over 10 squared. So then that's going to give me, a negative squared is going to give me positive. So I've got 91 over 10 squared is 100 minus 3 squared is 9 over 10 squared is 100. So then we have 91 minus 9 is going to give me 82 over 100. These are both even, so I can factor out a 2, and I get 41 over 50. All right, so now I've got sine 2 theta and cosine 2 theta. Now it's time to do tangent of 2 theta. So tangent of 2 theta is a little bit messier because we got some division going on, and that's going to require us to have 2 times the tangent theta, and tangent theta is negative 3 square root of 91 all over 91, the whole thing over 1 minus the tangent theta squared. So I'm going to go ahead and use this one since I'm squaring it so that it gets rid of that radical and doesn't make the numbers huge. So then we've got negative 3 over square root of 91 squared. Okay, so then in the numerator I have negative 6 square root of 91 all over 91. In the denominator I have 1 minus negative 3 squared is going to be 9, and then the square root of 91 squared is just going to be 91. Okay, so if I multiply everything through by 91, that's going to clear up the fraction within a fraction. So let's go ahead and do that. So distributing this would give me negative 6 square root of 91, and then this would have to go to both of them. So then I have 91 minus the 91s cancel out, 9, which is going to give me negative 6 root 91 over 82. Well, 6 and 82 have a like factor of 2, so then that gives me negative 3 root 91 all over 41. Okay, so before I do anything else, I want you to take a look at this and compare it with your sine. Just a second. So I want you to take this and compare it with your sine, and then compare it with the cosine. And remember, the tangent is sine over cosine. So that would be sine over cosine. So that's negative 3 root 91 over 50 all over 41 over 50. And then the 50s would cancel out because they have a common denominator. And you have negative 3 root 91 over 41. So do you have to go through all of this work? No. If you have the sine 2 theta and the cosine 2 theta. But if you don't, then yes, you do. So if we have the sine and cosine double theta, double angles, then use the tangent property. So tangent of 2 theta would be equal to sine double theta over cosine double theta. And that's going to save you from all of this messy work. Okay? Okay, out of all of them, I think that one is actually the hardest one. Okay, so now we're taking a look at example 2. Write the following expression as the sine, cosine, or tangent of a double angle. Then find the exact value of the expression. Okay, so this is the expanded form. I have to put it in its condensed form. So I've got 2 sine something, cosine something. The only one that matches this is the sine 2 theta. So this is going to be the sine double theta. All right, but I need to know what theta is. Well, theta is what is the, for lack of a better word, the object of my tangent functions. So theta is going to be 75 degrees. Okay, so then I have to plug this in. So that's going to be sine of 2 times 75 degrees, which is going to be sine of 150 degrees. And then if I look at my unit circle, 150 degrees is right here, and the sine of 150 degrees is 1/2. And that would be the answer. That's all you have to do. Okay. All right. Looking at example 3. This one is using a half angle. So now we're going to the half angle formulas. So this is going to be over here. Okay. So looking at your sheet, it is the third box on the right. But again, those are all right here just for reference so that you can see them. So it says use a half angle formula. That's kind of giving you context clues. Hey, use that. Okay, so then that means I'm using sine of 105 means I'm going to use that sine formula. Well, sine of 105 equals sine of alpha over 2. So that means 105 equals alpha over 2. Or I multiply both sides by 2, and alpha equals 210 degrees. Okay, so why do I need to know that? Well, if you look in the formulas, we have cosine of alpha, cosine alpha, cosine alpha, sine alpha, cosine alpha, cosine alpha, sine alpha. So even though we're given the half angle, we need to find actually what the angle is. So, or what the full angle would be. So if this is 105, that's half of the angle. So that means the full angle is 210. And we need this because 210 is a number on our unit circle. 105 is not. Now, sometimes the numbers they give you, they will end up on here. So you have to be very, very, very careful. But in this case, it's kind of a context clue. 105 is not on here, so double that, 210, and there we go. So it's a 7 pi over 6. All right, so using this formula, I get plus or minus. Okay, we'll hold the phone, as Grandma would say. This is 210 degrees. So 210 degrees is down here in this third quadrant. Well, with respect to that, we know that our sine function is positive here and here. So down here, the sine function has to be negative. So this is going to be negative square root of 1 minus the cosine of 210 degrees all over 2. All right, so the cosine of 210 degrees, so that's going to be the x coordinate, is negative root 3 over 2. Excuse me. So it's negative 1 minus negative root 3 over 2 all over 2. Sorry. Minus a negative makes that positive. So then we have negative square root of 1 plus root 3 over 2 all over 2. Okay, we have a fraction within a fraction, so let's go ahead and multiply the top and bottom by that least common denominator to get rid of it. And that's going to give us negative 2 plus the square root of 3 all over 4. Okay, this is an acceptable answer because we have so much going on, but we can also say this gives us the square root of 4 in the denominator. So then we've got negative square root of 2 plus the square root of 3 all over 2. I would accept both of these for full credit. Just make sure that they would have to, either one would have to be negative because it is in that third quadrant. Okay, pardon me. The last example we have is going to be number 48. You guys are doing the odds, so I felt it would be a good idea to do one of the evens as an example. So cosine of theta divided by 2. So that tells me I am using this formula here. So that's going to be square root of 1 plus cosine alpha, the whole thing over 2. Okay, now I am given triangles with values, and they all, well, these have everything listed and they're all positive. So that means I'm going to just look at just the positive for this. Okay, now if I were told to look at this one, which if you have one that is alpha over 2, separate from this one, then you would need to find this missing side first before you do anything else. But given that this is cosine, and we know cosine is adjacent over hypotenuse, in respect to theta right here, this would be adjacent, this is a hypotenuse. So then cosine of theta is going to be 4 over 5. Okay, so now using this formula that we have, cosine of theta over 2 is going to be equal to positive, because these are all positive, 1 plus cosine, which in this case was 4/5, all over 2. All right, so you can clean this up in whatever fashion you want to. I look at this and I can multiply both the top and the bottom by 5s to get rid of the fraction. So that is one possible way, right? So then I have the square root of 5 plus 4 over 10, which is going to be the square root of 9 over 10, which would then be 3 over square root of 10, which is 3 root 10 over 10. All right, that's it. Sorry that took as long as it did. I wasn't intending to, so hopefully you guys can put it on like 1.25 playback speed or something. If you have any questions, let me know.